one pair of parallel sides. So there's three types of trapezoids. There's a regular old trapezoid, a right trapezoid, or an isosceles trapezoid. So the parallel sides in both of these are AB and DC. So in all three, we're going to mark these parallel. Now, as far as these being super prevalent on the ACT, not so much. It's mostly just understanding that if it's got 4 angles, that it adds up to 360. So that's the biggest part, the n minus 2 times 180. Where you take the number of sides, subtract 2, and multiply by 180. So you can get a little more specific with the classifications. This is super lagging. Oh well. A right trapezoid is just a trapezoid with a right angle. So a right trapezoid is a trapezoid with a right angle. There will be 2 of them. So in the center, that one is the right trapezoid example. So angle A and angle D would be your 90 degrees. So the right trapezoid is the trapezoid where you have one 90-degree angle, or 2 90-degree angles technically, because these 2 will both always be 90. Now, an isosceles trapezoid is basically like an isosceles triangle. It's got 2 equal sides. So it's a trapezoid with 2 congruent legs, which is a vocab word we'll talk about in just a second. But the legs are the non-parallel sides. So that would be like here and here. Another thing about trapezoids is that they have base angles as well as bases. So in our picture, if it's isosceles, these 2 angles will equal each other. So A and B will be the same, and D and C will be the same. And that's only true if it's isosceles. So if it's isosceles, then you will have congruent angles within the shape. If it's not isosceles, then they just add up to 360. So to kind of go over some basic vocabulary, I'll zoom out just a little. The base, those are the parallel sides. So the base of a trapezoid, those are the parallel sides. There are 2 bases. There's a top and a bottom because they both have to be parallel with each other. So unlike an isosceles triangle where there's only 1 base, in a trapezoid there are 2 bases. And those are the sides that are parallel to one another. So bases are parallel. You might want to grab more colors if you are. I would grab like one of each, because I think on the next page we're going to use a little bit more. Okay. All right, so base, those are the parallel sides of this shape. So the bases are the parallel sides. The base angles sit on the base. So base angles are only congruent if the triangle is isosceles, or trapezoid is isosceles. So we'll talk about base angles next. Those are 2 angles that share a base. So base angles, they sit on the base. There are 2 pairs because there's 2 bases. They will share 2 different locations. So it's 2 angles that share a base. So in these pictures, for example, it would be like A and B. So angle A and angle B, as well as angle D and angle C. So those would be your base angle pairs. The base angles will only be equal if the trapezoid is isosceles. And then last, you have the legs. The legs of the trapezoid are the non-parallel sides. So So in your picture, that would be like AD and BC. Those would be referred to as legs. So this side and this side. So the sides that are not parallel, those are the legs of the trapezoid. The legs are only equal if the trapezoid is isosceles. So a lot of the times you'll be dealing with isosceles trapezoids because there's a lot of congruency in them. So the isosceles trapezoid is the one you'll probably use the most often. Okay. So the last little piece is called midsegments. And then page 14 is just a couple theorems. So a midsegment goes through the middle of a trapezoid. So a midsegment is a segment that joins the midpoints of the legs. And I'm going to draw a picture over here. And we'll talk about the midsegment theorem on the next page, but I didn't want to crowd the picture, so I'm just going to draw isosceles trapezoid. And all a midsegment does is connect the midpoints. So this piece and this piece are equal, and these are equal. So the midsegment goes through basically the center of the trapezoid. There is a midsegment for triangles. But again, it's not seen on the ACT as much. So down at the bottom, take a second and just classify what kind of trapezoid you see. Be as specific as possible. If it's not right or it's not isosceles, then it's just a trapezoid. All right. So isosceles, then right, then trapezoid. So on the next page, all we're going to do is talk about just some trapezoid properties that are important, and then we'll kind of move on to kites, and then hopefully summarize everything up together, which is the end goal. There's a lot to do with quadrilaterals. It's a lot. So if you haven't watched the videos for the quadrilateral flowchart, those are still up there as assignments, so you can definitely watch those to fill in your notes. All right. So the first two trapezoid properties are for only isosceles trapezoids. So property number 1 and property number 2, that's for isosceles only. So the one on the side, only number 1 and number 2, those are only for isosceles trapezoids. The rest, like the third one, will be for any trapezoid. So 1 and 2 are only for isosceles trapezoids. 1 and 2 are only for isosceles trapezoids. It's basically just some information regarding them. If they're isosceles, then these two things will always be true. So for the first one, okay, in an isosceles trapezoid, this only works if it's isosceles, the base angles are congruent. And we did talk about that already, but it is a property for isosceles trapezoids. So that's why I'm just going back over it one more time. So the way that you find the base angles, or you look at the base. So the base, those are the sides that are parallel to each other. And the base angles sit on the base. So if you're looking at the first picture, this is the first base, AB, which means angle A and angle B are going to be equal. because they sit on the same base. So you find the bases by finding the parallel sides. The angles that sit on the base are called the base angles. And then you have another set of base angles, which is for the bottom base. So these two, that would mean that D and C are equal. So angle D and angle C are the same. So to find the base angles, you find the base, and the base angles sit on the base. Okay. Now, back from geometry, there are angle pairs that add up to 180, and those angle pairs exist inside of the trapezoids. So base angles are actually inside of the angle, sitting on the bases. Okay, sitting on the bases. There are two pairs of them. They are only congruent, though, if it's isosceles. So again, this is only true for isosceles triangles. Okay, only isosceles triangles. Now, A and D will add up to 180. So these angles here, a long time ago in geometry, you learned about alternate interior, alternate exterior, which we will talk about at the end. But if I cover up this angle, you can see kind of the parallel lines cut by the transversal. These two angles will add up to 180 because the lines are parallel and they're being cut by a transversal. So we will cover that. That's the last thing we cover in this topic. So angle A plus angle D is going to equal 180, and that is true for any trapezoid. So it doesn't matter what type. The angles that are on this that share basically a leg, they're going to add up to 180, and then the same is true on the other side. Angle B plus angle C will also equal 180, and that is true for any trapezoid. So any trapezoid, that will be true for. So base angles are the same if the trapezoid is isosceles, and then those angles on the side will always add up to 180. The last part, again, is just for an isosceles trapezoid. So in an isosceles, oh, I can't spell. There we go, close enough. In an isosceles trapezoid, the diagonals are congruent. So diagonals connect one vertex angle to the opposite vertex angle. So in our picture, that would be like A to C and D to B. So this distance is the exact same as this distance. So the distance from segment AC, it would be congruent to segment DB. So this distance here, the whole entire thing, is equal to DB. Now, where they intersect, that's not a midpoint. It doesn't break it up into 4 equal parts like in a rectangle, but it does cut this whole thing in half and this whole thing in half. So like these two pieces are the same and these two are the same. And then as all of it, AC as a whole is the same as DB as a whole. Again, only true for isosceles trapezoids. That's it. Now, the very last one is about any kind of trapezoid. So this will work for any. These first two is just for isosceles, whereas the last one is true for any kind of trapezoid. So these first two are just for isosceles. And then the last one is for any type of trapezoid because it involves the mid-segment. No. I can smell just a little. It's been torture because I like to cook, and cooking without being able to smell anything is the worst. But it's coming back slowly, which is nice. My husband can't smell, so he made fun of me, so now I get to make fun of him. But he can smell. Yeah. Is for any type of trapezoid because it involves the mid-segment, and the mid-segment is in all types of trapezoids, so there's nothing special about this last one. Just know that the first two are only for isosceles, which is the important part. And then this bottom piece is for any type of trapezoid. So in any trapezoid, the length of the mid-segment, so we are going to draw a mid-segment here, is half the length of the sum of the bases. So this final theorem about trapezoids works on any type. It involves the mid-segment, which connects the midpoints of the legs of the trapezoid. So connect here, and this is our mid-segment measure. So the mid-segment goes through it. The length of that segment is half when you add base 1 and base 2 together. So when you add the top and bottom and divide by 2, that will give you the measurement of the inside. So I'm going to call this base 1 and this is base 2. So the formula is mid-segment equals 1/2 of base 1 plus base 2. So in these problems, the mid-segment goes through the center. The mid-segment also connects the midpoints. So remember, these two are equal and so are these. And basically all I do is add the bases and divide them in half. No, because you're adding them together. I just label top to bottom. But it doesn't matter which one base 1 or base 2 is. Somebody's got something's out there. I don't know what I can hear. Yeah, but it doesn't matter which one base 1 or base 2 is, as long as you're just adding the top and bottom together. And then divide it in half, and that's the length of the center. And then to finish up trapezoid, we're going to talk about area. I know it says from unit 2. Basically, I just forgot to wipe that part out because this is from geometry, and we talked about it in unit 2. So we did not learn this in unit 2 of our class, but so the area formula for a trapezoid, we will go over in great detail after circles, but I just want to talk about it since it's here. The way that you do the area for a trapezoid is it's 1/2 base 1 plus base 2 times height. So base 1 and base 2, again, are here. And then the height is the distance between. So the area formula for a trapezoid, you add the bases together, divide by 2, or multiply by 1/2. It's basically this mid-segment formula, but multiplying by 1/2. Here. Here. So it's 1/2 base 1 plus base 2 times height. It's basically the mid-segment formula right here. It's basically the exact same thing, but then you just multiply by height. And that will give you area. But we'll spend plenty of time going over area of all the shapes. We'll spend plenty of time doing all that. So, but since we're on trapezoids, I just want to talk about it real quick. One final thing about trapezoids is that they are not parallelograms, because parallelograms have 2 pairs of sides equal. Trapezoids only have 1. So on the bottom it says that they're not parallelograms, so just be mindful of that. Only 1 pair of parallel sides, which is what a trapezoid is. And we will spend plenty of time reviewing these kinds of shapes because I know that they're new. Well, they're not new, but it's been a while. So to finish up, we're going to do kites on the next page. And then we're just going to kind of talk through the flow chart, which is on page 16. So, and that's all we're doing today. And then we'll do circles tomorrow. I just want to finish up trapezoids and kites and just be done with polygons. So we're going to be on page 15. Kites are really not on the ACT that much, but I do want you to just have seen them. So you're not like, I don't know what this is. So kites, they're not necessarily big on the ACT, but they're very quick to learn. So we can go over those properties fairly quickly. So we're going to go over just their properties. The odds of you really seeing a kite, pretty slim, but they're short enough for us to go over them pretty quick. So a kite, this is a quadrilateral with no parallel sides. So there's not really much to them. They just don't have any parallel sides. Basically, everything intersects somehow. Now, there are things called right kites. Right kites have a 90-degree angle. So a right kite is a kite with a 90 degree. W is like, okay. Now, it can have 1 or it can have 2 90-degree angles. It depends on where they're located. So a kite could have 1 at the top. So it's called a right kite because it has a 90-degree angle. So it could have 1 or it could have 2 if they're across from each other. So there are, just depends. I thought you were going to puke in the trash can. No. All right, so there are 4 kite properties. So 4 total kite properties. Okay, Josh. They're fairly quick. This is true for all kites. There's not like an isosceles kite or anything like that. So the first kite property is that both pairs of consecutive sides are congruent, but not opposite sides. But opposite sides are not congruent. So this is kind of similar to the parallelogram, but the parallelogram, the opposite sides are equal, whereas kites are consecutive sides. So that means that the top 2 are equal and the bottom 2 are equal. It kind of splits it top and bottom. So you've got the top that's the same, and then the bottom. And based on the picture of the kite, you can kind of tell that they're the same. They're pretty much drawn to scale. So you can look at the kite and pretty much know, hey, these 2 sides are the same, these 2 sides are, just based on how it looks. So in the kite, you've got the top part that matches, and then the bottom part that's also the same. Next is about the angle. So number 2, exactly 1 pair of opposite angles are congruent. And the 2 that are equal are going to be the ones that are in between the sides. So again, the top and the bottom are the same. So the 2 on the top and the 2 on the bottom. The angles that are equal are between those 2 sides. So like angle A and angle C. So the ones where the sides of the kite are equal, where those meet, those angles will always be the same. Those won't be the same. It's because these side measurements are different, so that's going to make the angles different. Whereas these, they each have 1 bar and 2 bar, making them the same. Yeah. Yep. All right, number 3 is about diagonals. The diagonals are also perpendicular. So number 3, the diagonals are perpendicular. So perpendicular means they cross at 90. And the symbol for perpendicular is an upside down capital T. So if we were to connect A to C, then B down to D, all of these would be 90. And that's the same for a rhombus. We learned that on the flow chart. And it's also the same for a square. Okay. So they'll always make 90 degrees. And last is about the angles B and D. Those will be bisected. So the last piece is exactly 1 pair of angles are bisected. So whenever you have your diagonals happening, they will cut angle B into 2 equal angles here and here. Those 2 top pieces will be equal, and then the bottom 2 will be the same. A and C do not get cut evenly in half. Only B and D, the top 2, the top and bottom. So on the bottom, we're going to put it all together, just like what you did with the parallelograms and how to label the pictures of things that are equal. So the first thing, we're just putting all of these properties onto one shape, just to kind of summarize all of them together. So the first important thing is that the 2 top pieces are equal and the 2 bottom pieces are equal. So this one and this one, this one and this one. So that's the first property of your kite. The next property is about the angles, but we'll talk about that after we do the diagonals. So the diagonals will cross at 90. Okay, these will be 90. Property number 4, 1 pair of angles is cut in half. So we've got these 2 up here, and then these 2 down at the bottom. That line is not very straight, oh well. Now, as far as angle A and C are concerned, those are not cut in half. So what that means is this top portion is the same as this top portion. It's not bisected. Right? It's not cut in half. And it's kind of weird, but the only angles that are cut in half are the top and bottom. And then you have the bottom pieces. these two. So what you actually end up having are isosceles triangles. You've got two of them. You have an isosceles triangle on the top, and you have an isosceles triangle on the bottom. So let's see. So you end up with two isosceles triangles. They're not equal, but they're isosceles. So that's kind of all of the properties of kites together. Again, kites aren't that prevalent on the ACT, but there's not that many properties to them. All right. Now we're going to finish on page 16, which summarizes everything together. Okay. And then that's where we'll stop for today, and then I can look up your IXLs and stuff. Yeah, I'll pull them up. You worked on them? Okay. I'm going to update them on Wednesday. So the very last page is page 16. I'm going to zoom out so you can kind of see it all. Since you have this kind of in front of you, it's really hard for me to kind of show you everything. Basically, this has all of the properties up here, so I'm going to just show you this bottom part because the top part has the shape. The bottom part has all the properties. So this is basically everything that you've learned already, just kind of in one spot. Let me pull up. Okay. So the first property, we're going to use like all the colors. So basically, I'm just going to color in the top right here. It's going to be hard. So this is quadrilateral, so I'm just going to shade it in. That property corresponds down here. So I'm just going to keep it down here. Basically, I'm just coloring the shape, and then I'm matching the property. A quadrilateral has four sides. Like that's basically its whole purpose. It's got four sides. Okay. The total degrees of a quadrilateral is 360 because n minus 2 times 180. 4 minus 2 times 180 is 360. Okay. Next, we move over to the left-hand side. This has two pairs of opposite parallel sides. Two pairs of opposite parallel sides. That's parallelogram, rhombus, rectangle, square. So this whole section, its main purpose is that it has two pairs of opposite sides that are parallel. So up top, I'm just going to kind of draw a box around all those shapes. I just chunked the. You can color them. It's fine. Did you mess up?
Yeah, she put it over the top.
That's. You can. That's fine. They're the same. It's the exact same thing. One's just pictures. One's with words. Yeah, it's not a big deal. You learned about the parallelograms when you did the flow chart. Okay. And the flow chart, that was on page 11 and 12. So if you need help with these. Did you mess up? How did you mess up? Okay. Parallelogram, rhombus, rectangle, square. The next one is kite and right kite. Those have no parallel sides. And we learned about those on page 15. So kite and right kite. It has, again, all of the properties just written out. This is a good little summary page. And then I'm just going to box in kite and right kite up here. Don't cover trapezoid. Okay, so this is all it looks like. I'm just boxing in the letters. You can color the shapes if you want, if that's easier. It's up to you. But just kite and right kite. And the very last one is trapezoid. It has one pair of parallel sides. And we did trapezoids on page 13 and 14. So the goal of this final little flow chart is it has every single property on it, like every one we've talked about. It's a lot of info. That's why I think that this little flow chart is the best, because it summarizes them all together. And it has all the notes kind of in its own thing. It's got pictures and shapes. So it just summarizes every single property that we've talked about. After this, tomorrow we're going to be doing circles.